Picture this. A machine weighing hundreds of tons is sitting on the runway. It's packed with passengers, loaded with luggage, carrying thousands of gallons of fuel. A few minutes later, it's cruising 35,000 feet above the Earth. Sounds impossible, right? But here's the crazy part. Most people think the engines are what keep an airplane in the sky. They're not. Yep, that's one of the biggest myths about flying. So if the engines aren't holding it up, what is? How can something heavier than a building suddenly leave the ground, stay in the air for hours, and land exactly where it's supposed to? The answer isn't magic. It isn't luck. It's one of the smartest engineering tricks humans have ever discovered. And once you understand it, you'll never look at an airplane the same way again. Let's get into it. The moment an airplane starts rolling, it's already fighting a battle. Not against another airplane, but against four invisible forces. Think of it like an invisible tug-of-war happening every single second. One force is trying to pull the airplane down. Another is trying to lift it up. One pushes it forward, and another tries to slow it down. Those four forces decide whether an airplane flies or stays stuck on the ground. Gravity pulls everything toward Earth. That's the airplane's weight, no matter how powerful the aircraft is. Gravity never takes a break. To beat gravity, the airplane needs something even stronger. But now an airplane and it's just a very expensive bus driving. But wait, that creates an even bigger question. Where does lift actually come from? Because airplanes don't flap their wings like birds. So how do they create an upward force out of thin air? Here's where things get fascinating. Take a close look at an airplane wing. It isn't flat. The top is curved. The bottom is much flatter. That shape is called an airfoil, and it's the reason airplanes can fly. So, if the engines aren't actually holding the airplane up, what are they doing? Here's the answer. Their main job is surprisingly simple. Keep the airplane moving forward. That's it. And that forward motion is exactly what the wings need to keep producing lift. The moment the airplane slows down too much, less air flows over the wings. Less airflow means less lift. If the speed drops below a safe limit, the wings can no longer generate enough lift. That's called a stall. Contrary to what many people think, a stall doesn't mean the engine suddenly quit. It simply means the wings aren't getting the airflow they need, which is why pilots constantly monitor airspeed. Because in aviation, speed isn't just about going faster. It's about staying in the air. Now let's talk about the real powerhouse of the airplane, the jet engine. At first glance, it looks like a giant metal tube. But inside, it's performing thousands of explosions every single minute. Here's what happens. A massive fan at the front pulls in an enormous amount of air. That air is squeezed tighter and tighter by several compressor stages. Then fuel is injected. The fuel-air mixture ignites inside the combustion chamber. The hot expanding gases rush through turbines before blasting out the back at incredible speed. That creates thrust. But here's something most people don't know. On modern passenger jets, most of the thrust doesn't come from the fiery exhaust. It comes from that huge fan at the front. It pushes an enormous amount of air backward. And thanks to Newton's third law, the airplane is pushed forward. That's why today's turbofan engines are far quieter, far more efficient, and far more powerful than older jet engines. Okay, the airplane is flying. But how does the pilot actually turn something this massive? Believe it or not, there's no steering wheel. Instead, the pilot controls tiny movable surfaces built into the wings and tail. Pull the control yoke back, and the elevators move. The airplane's nose rises. Push forward, and the nose drops. Want to turn left? The ailerons move in opposite directions. One wing creates slightly more lift. The other creates slightly less. The airplane banks and naturally begins turning. Meanwhile, the rudder keeps everything coordinated, preventing the aircraft from skidding through the air. Every smooth turn you feel during a flight is actually several control surfaces working together in perfect harmony. But takeoff and landing are a completely different game.